So in day 2, what we're going to do here is kind of put everything together and expand some expressions using the binomial theorem. Okay? The homework will take you a little, I shouldn't say a little bit, a little beyond, I guess. I think I'm going to do 3 with you, and I gave you 2 that are third power and 1 that's fourth. Don't be surprised in the homework or a quiz or a test that I go up to like 5, 6, or 7. If you recognize the pattern, it's not a real big change. There's more terms, but if you go back to the triangle that we finished day 1 with, I think we went up to n equals 8. So you have all the coefficients ready to go. Okay? But for now, we'll go 3 or 4. So big picture what's going on with these is we're expanding an expression, right? Again, the most common way you have done this is the FOIL method, which works pretty well if n is 2. So notice we're focusing on cases where n is over 2, and if you wanted to use the distributive property, you could. You're going to see pretty quickly you're not going to like it. It gets pretty messy. All right? So I'm going to put 2 things together on this one. Number 1, for each term, is our coefficients. Now you don't need to write this out, but I just want you to remind you. If you look at that row of Pascal's triangle, we would see 1, 3, 1, 1. Okay? We're going to have 4 terms. Those are the 4 coefficients. So with term number 1, our first term x starts high. Our second term is 1. Its power starts low. Okay? For each of the next 4 terms, the power of x goes down, the power of 1 goes up. So for term number 2, we would have 3x squared times 1 to the first. Okay? We're not going to leave it like this. We're kind of getting everything written out to expand it, and then our second step will be to simplify it. Coefficient for the third term is 3. X drops to the first power. 1 hops up to the second power. Final term, x is now down to the 0 power, and 1 is up to the third. Okay? So it's expanded. Now obviously there's a lot of simplifying to do here. For example, with the first term, that's just x to the third. The second term is realistically just 3x squared. Third term is 3x. Last term is 1. There you have it. Okay, that third degree expression we fully expanded using the binomial theorem. It's another case where to compare it to what it would be like using just the distributive property, I should make you do it, and maybe in class I'll go through one and show you what that would look like as to how ugly it is. But this was a pretty efficient way to expand that expression. All right, let's go and do a fourth degree. Okay? We're going to have 5 terms. I looked to Pascal's triangle at the row labeled n equals 4, and there's our 5 coefficients. Okay, now this one's got a little bit more going on. Okay, so like in our first term, there's our coefficient. Our first term is 2x, so that's what's raised to the fourth. Negative 3 is to the 0. Okay, we've got the 4 other coefficients, and then just remember the pattern with our exponents. That first term is going to go down and the second term is going to go up. Coefficients 4, 2x is now to the third power. Negative 3 is now to the first. Another one of those spots where maybe not a bad idea to pause to see. We got 3 terms left. Can you get them? Six is the coefficient. Both of the powers are 2. You saw this on the first one because you'll see it on all of them. This is a case where n is 4. Notice how on every single term the exponents add up to 4. Okay, not a coincidence there. That's a part of the pattern. Second to last term would state 2x to the first, negative 3 to the third. I'll scoot this over just a little bit. Two x to the 0. And now it is negative 3. That should be to the fourth. Okay. So now remember, with all that like n choose whatever stuff that went on, just kind of a random thing to throw in here. You know, like this 6, we got that from the triangle. That 6, like that particular coefficient, that would come from 4 choose 2, right? So if you're like kind of wondering that, hey, what happened to all the 4 choose this, we did all that kind of stuff in the first day, remember the triangle and the pattern we recognized kind of replaced doing all that work. All right, so kind of go term by term here. Simplify them one at a time. So remember this exponent that's a 4, that goes to the 2 and the x. Meaning that's really what our first term turns into, is 16x to the fourth. Because 2 to the fourth power is 16. Negative 3 to the 0 power is 1. Okay. For the second term here, it'll be x to the third, but that 2 needs to get cubed, then multiplied by 4, then multiplied by negative 3. End result will be negative 96. Okay? Notice how that one becomes a subtraction. And of course we had x to the third. All right, this next term will be x squared. That would be 4. 4 times 6 would be 24 times negative 3. Excuse me, not negative 3, negative 3 squared. So that would be times 9. All those coefficients multiply to get 216. And of course we have x squared. Here we'd have to do negative 3 cubed. That would be negative 27 times 2 times 4. That one actually also comes out to be 216, but it's negative. So we would have minus 216x. And really you can't quite see it here. Let me bump it over so you can. The last term, all we really have is negative 3 to the fourth. Right, because the 2x is to the 0 power, and that is 81. Okay. There's your final simplified answer. That one had a little bit more going on. It had a 2x instead of an x, had a minus sign instead of a plus, and then we upped the power to n equals 4 as opposed to 3. All right, we'll do one more. Just a reminder here, n is 3. So when I go to Pascal's triangle, I've got 4 terms. There's the coefficients I need to take from the triangle. Okay? And then for term number 1, this one's kind of interesting. You get an exponent with an exponent. Second term is 4. And that'll be to the 0. For term number 2, coefficients 3, x squared will be squared. 4 will be to the first. Third term, x squared will bump down to the first power. 4 will bump up to the second power. 1, x squared to the 0, 4 to the fourth. Okay? Good one to see because it tests us here a little bit on some properties of exponents. Like in the first term, what is x squared to the third power? It's x to the sixth. Okay? Most common mistake there is to say that it's x to the fifth. Okay, but that is a case where you want to multiply those two exponents. See, 3 times 4 would be 12. Power would be to the fourth. 16 times 3 would be 48 with an x squared. X terms are gone by the last term, and 4 to the fourth is 64. So there is that expression fully expanded, again using the binomial theorem.